Hello?
Hello? Hi, can you
Hey,
hear
how's
me?
it going? Yep,
Good,
it's
how are
working
you?
fine.
Yes, okay,
Pretty well.
perfect. Awesome. Okay, so I guess before we start, just wanted to let you know a little bit about the format. So we'll probably go for like 45 minutes. I'll ask you to just tell me a little bit about your background and experience so I can like gauge a good question level to ask. And then I'll ask you a little warm-up question and then a follow-up question. And yeah, does that sound good?
Sure.
Okay, cool. So yeah, I guess, do you want to go ahead and tell me a little bit about your experience?
Sure. So I'm a student studying computer science in Canada. I started programming in high school and I guess continued with that, where I ended up working a little bit at my university and then at some other tech companies for internships over the summers. For using interview.io, I guess I was preparing for some interviews that I had coming up. I also wanted to see, like, what it was like.
Mm-hmm. Sorry, I think you cut off a little bit. Can you still hear me?
Yep, I can hear you.
Oh, okay, cool.
Sorry, which part cut off there?
I heard last word I heard was interviewing.io.
Oh yeah, I was just preparing for some interviews that I had coming up, so I was on interviewing.io for that, as well as to see like what the platform's like.
Gotcha. Cool. So are you do you have any interviews coming up?
Yeah, on this
Okay.
Friday, actually.
Okay, cool. What's like your preferred programming language?
I think usually Python.
All right, cool. I guess I'll go ahead and switch it over. Do you have a preference between Python 2 and 3?
I guess I'll select 3. I think
Okay.
it depends on some of the questions, right? Because there's some things that are weird with 3 and, other way around as well.
Yeah, I mean, I guess in the interviews, though, it usually doesn't matter because they probably won't ask you to actually compile code.
Right.
But yeah, okay. I guess to get started, are you familiar with binary trees?
Yep.
Okay, cool. So the warm-up question then is to perform in-order traversal on a binary tree, and you can just print out every node value that you see. And you can assume that the values in the binary tree are integers.
Okay, sure. So am I allowed to have any sort of memory on the stack? So like, can I do this recursively?
Yeah.
Okay, so assuming that I can do this recursively, you said this was the in-order traversal, so all I'd have is that I just need to have my left subtree called with in-order traversal, then I print off my root value, and then I'd want to, have the in-order traversal of my right subtree. For the actual time complexity of that, it ends up taking big O of n time, and then the space complexity is pretty much the stack, which I want to say should be the height of the tree. So if it's just a really long tree, that could be kind of huge, but if it's like a perfect or balanced binary tree, then it's like log n. You said it's just integers, but if I'm using print, I don't think it'll make too much of a difference as long as it is representable. Is it okay if I code that out?
Yeah, that sounds good.
And the one thing I didn't mention is that my base case is when my root is none. I also didn't specify the structure of my actual tree node. Is that something that I'm given, or is it something that I can just make up?
You can just assume that it's given to you, and your structure is like a node, and it has a pointer to its left and right child, as well as the integer value.
Okay, so that. Then I guess I'll assign. Sure. So I'm pretty sure that code ends up being okay. Would you want me to test this, or do you think that's kind of okay?
No, this is okay. Yeah. Why don't we move on to the follow-up questions? Looks good to me.
Sure.
So for the follow-up, are you familiar with binary search trees?
Yep.
Do you want to just go around the page? Do you want to like define that for me?
Sure. Yeah. So a binary search tree is like a binary tree, except for all of the nodes, you have a constraint that your node value is or your left subtree is less than your node value is less than your right subtree. And then there's, variations where you have the like less than or equal to, or only the left side is less than or equal to, and then the right side is less than, and that repeats throughout all of them.
Okay, great. Yeah, that sounds good. So the problem is, given the root node of a binary search tree and also a value, I want you to write a function to find the in-order successor of that value.
Okay.
So for you. So you can go ahead and like run through some examples if that's helpful to you.
Sure. So I'm going to assume that the structure for the nodes are the same as last time, right? There's no like parent pointers or anything of that sort?
No.
Okay. Let's see. So normally when I have the in-order successor, the thing I'd want to pick is either that if there is a right node, I want to pick the node that is as far left possible on that right subtree. So for example, for the node at 10, my in-order successor should be that 30, because I'll go to the right subtree and then as far left as possible. Otherwise, if the right subtree doesn't exist, what I should probably want is the first parent node that is that has my node as part of its left subtree. So the in-order successor for 7, not 7, let's say 9, should be 10, right? Because that's the first time that my node is the left successor, or it's part of the left subtree. So for actually coding that out, let's see. What am I allowed to assume that I'm allowed to assume, I'm guessing, that I get the root as well as the node as my input, right?
So, no, so the input would just be the root node as well as an integer value. And
okay.
So the goal is to return the successor of the integer value.
Right. Okay, so it's the similar. I'd get the root node and the node that I want the successor for. But are the values unique in that case if I get just the integer?
What do you mean by unique?
So am I guaranteed that there's only, say, like 1, 7?
Yeah, we can assume that the values in the tree are unique.
Okay. For how this is actually structured, or how I'd figure it out, I guess those are the two ways that I would get it. I think it's probably helpful if I try to code something out, because even though I get that as an idea, I think I'll have to think a bit about how I get the parent case
Sure.
without going upward.
Okay, cool.
See, so I start off at the root, and I know that if my target is less, I'll always have this candidate, which I think initially I would have as none. And every single time that I'm either going left or right, I should end up having to update my candidate. So the way to determine whether I should go left or right is definitely based on the value. So say if the target is less than root.value, but this assumes that root also exists, right? If it's less than root dot value, then I should update my candidate to root. No, that sounds wrong. That's the.
Well, if you're already because you're currently comparing your target to the root value, are you sure you want to set the candidate to the root?
Yeah, that's what I was just thinking. That's not what I'd want to do, right? It's I mean, it does work out in the case that say I have my 1079, and I have that my target is less than the root value. My candidate is supposed to be the root, but it's not going to stay like that in the else case. I'm pretty sure.
Right. So I guess the hint, maybe sort of turn the loop into sort of like searching for the node value that contains the target, and then focus on finding the target's successor node, if that makes sense.
Right, but one of the things I was thinking is that the only case that you can have your candidate updated is when you go to the left. When you end up going rightward, I don't think your candidate should ever update, generally, because...
Sorry, is your candidate a representation of the actual successor that we're trying to return, or is the candidate holding... Okay.
Yeah, the candidate's supposed to be the successor, so that's kind of why it was set like that.
So if we're going right, so let's say I give you a target of 35, so the candidate should then be 45. 45 is the in-order successor of 35. So how would you handle that case?
Right.
And how would you even search for... We would have to like iterate through the tree to first find the node that contains the target value, which is 35 first, is what I'm trying to get at.
Right, and I was thinking that there should be a way that you can go through once without having to do that. Because even if you find that that value or that node where that value exists, it's only in the case where your successor is in that right subtree that you don't have to search again. Knowing where the successor is doesn't really give you, doesn't really help you solve the problem much when you end up having it that it's one of the parent nodes, because you'll still have to do the traversals again.
I guess, do you have to do the traversal again, is my hint? Could possibly try and figure out a way so you don't have to iterate up the tree more than once.
Up the tree?
Because the issue
wait. Sorry, you can go ahead.
I mean, the issue is you can't go up the tree, so you're going to have to figure out a way in order to do that.
Oh, I guess I should have asked as a clarifying constraint then. Am I allowed to modify the nodes? I assumed I couldn't.
So you can't assume that there is no parent pointer.
Right, okay.
Okay, so I guess for now, though, since we're sort of stuck on the parent part, why don't we try and put out the edge case such that we're finding the successor when the node has a right child, since you've already clearly been able to figure that out. So let's just tackle that edge case first.
Right. So it would be that I have a separate while loop that if I do find the value, like this, if I were to write it separate, it would end up being if inner root equals the root dot value equals target, then and root dot right, while make root equals root dot right, then you say while root left equals left. That's kind of, if you were to have it isolated on its own, that is what you'd want to have, that you just pick the leftmost on the right subtree.
Right. Okay. Yeah, that looks good to me. So I guess kind of to push us closer to the next edge case, the issue still is like you just have if root.val equal target. How are you going to like keep updating root until you get root.target? Like you haven't done a traversal to find the target node yet.
Yeah. Well, this part should not in the context. If this code exists on its own, no. But inside of here, there is a traversal where if the target is less than, we just go to the left subtree. If the target is greater than, then we go to the right subtree, right? Yeah, and if I were to keep the code as it was, this is probably the much better thing to do.
Mm-hmm. So, okay, so we're stuck on the part that
you have the parent.
Okay, so I guess, is there a way that you can keep track of something so that like you can mitigate the problems you're having?
What do you mean keep track of something?
I mean, so what are you stuck on exactly? Like, can you verbalize that to me?
Yeah, it's I thought that this would be okay, where I kind of set the candidate as being the root whenever I go leftward. And I thought that with all of this together, it kind of does cover both the cases. So, like,
okay, then yeah, okay. Then in that case, maybe run through an example and let's like prove that it works.
Sure. So what I end up having is, let's say I want the Inorder Successor of 9. I'll go ahead and have my candidate as none. My root is 10. So right off the bat, I see my target is root.value. Okay, I'll make my root become 7, and now my candidate is 10. Now my root is it's not meeting either of these conditions, so I know my root is less than the target. So I make root.right. I see that root.value is equal to target, but I don't have root.right. Now I'll make my root.right, which is none, and my candidate is 10, which is what I would want.
Okay.
The other case.
Okay, gotcha. Yeah, let's turn to the other.
The other case is when I have that. Let's say I wanted the successor of 7. This after the 9, there could be like a bunch of stuff here. I don't think it would make much of a difference. So this would be like 8. I think it'll still work out even if there's multiple nodes. But I'll start off with my root as 10. I'll see that my target is less than the value. Okay, so now my root is 7. My candidate is 10. I check my target is greater than, so I make my, it's not greater than. My root value is the target, and it has a right subtree, so I'll set my candidate to being 9. And then while I can move left, I just make the candidate left. That loop is done. But now there is an infinite loop here, because again, I have root.value is equal to the target. So the correct thing I'd want to do to fix this is kind of set root equals to none. Because I know that as soon as I get inside of this condition, I'm definitely done with the traversals.
Gotcha.
This definitely passes for like the empty case, and the main other case you have to care about is that your in-order successor is none. So that would happen for 45.
Right.
So if I were to go through for that, I see that I have root, my candidate is none, my value is greater, so I go right. Again, my value is greater than 35, so I go right. Now my root is equal to the value. I don't have root.right though, so again, I will end up in another infinite loop. So this would have to be separated. I think the thing I would end up needing is a separate if instead of this and, but that may change my other cases. So before I do that, I have to think about that.
Mm-hmm.
No, one of the cases was that I eventually reached that 9, right?
Right.
Yeah, I think this ends up working out better than what I had.
Yeah, that looks good to me. So I guess, can you analyze the time and space complexity?
Yeah, so from, because of the fact that we either go right or left, the time complexity should be, I guess, in big O of h. Yeah, h, because I can't assume it's balanced, and then the space complexity should be similar.
Gotcha.
Sorry, that's if I'm doing it recursively, which I'm not. So the space complexity should be constant.
Mm-hmm. And what would you define h to be?
The height of the BST.
Okay, and like, what if it were balanced?
It would still be big O of h, but in this case, when it's balanced, big O of h is going to be log of n, where n is the number of nodes.
Right. Okay. Yeah, that sounds good to me. All right. Well, that's all I had. I guess just some feedback before we end. I thought that you're super clear on like your algorithms and data structures, and you're pretty good at communicating. I guess the only advice that I would have is sort of like modularize your steps a little bit as you're going. So I thought it was really good that you're sort of like following the format that interviews look for, which is like talk about the problem, ask any clarifying questions before you start, also talk about your algorithm and propose it before you code. But I think sort of like as you code, you can sort of segment it so I can follow along a little more easily by being like, okay, so first I'm going to like tackle the root case where the root might be null and this is what I'm going to do. And then you can sort of like mumble and code it. And then be like, okay, now I'm tackling the edge case. So there's 2 edge cases, and it was good that you defined them. But then as you're coding, be like, okay, so first I'm going to like code the case where blah, and then do it. And then next I'm going to code the case for blah. And then, yeah, it was really good at the end when you proposed to run through some edge cases. So overall, I think you did really well. Yeah, okay. Do you have any questions for me?